but there are some who have not used a smartphone before. But also, to get access to broadband services, there are certain basic skills that, especially for the guys who haven't used broadband before, they might acquire those skills to be able to use the mobile broadband. Another point that is normally spoken about is lack of appropriate content applications. You really need to have something that you can offer for someone to say, okay, I can use my 1,000 to buy airtime instead of buying something else. So there has to be something that someone can identify with to be able to say, okay, I can invest in a smartphone and I can access this and these services that will be of value to a particular person. And the last point, of course, is affordability of CPEs and the airtime. From most of our meetings, always our answer was innovation. We cannot really solve this problem without going back to the drawing board. Okay? So the local industry has to innovate in a number of areas to be able at least to achieve what we are planning to achieve over the next 3 years. So at the Department of Electronics and Telecom Engineering, we've been working on different aspects of mobile broadband challenges and possible solutions. Because it's still early on, this is a long-term project for us, but we have already some ideas that we want to share with you at this conference. The first major point is there is a huge departure from voice-centric services compared to broadband services. So there has to be really a mindset transformation. As engineers, we've been working on between a voice-centric service and a data or internet service from infrastructure perspective. Voice is normally regarded as error tolerant. This means even in very poor connectivity situation, you can still make a voice call. But data or internet normally require a very clean connection. Okay, we can compare this to a rough road. Okay, voice being able to be provided on a rough road, but internet has always to have a very good road, or maybe tarmac road. Okay, this is really analogy I can give at this point in time. The difference between these results in huge differences in terms of coverage, in terms of capacity, in terms of many key performance indicators for broadband infrastructure. In fact, the ratio between voice and data in terms of power requirements is almost a ratio of 1 to 100, about 20 dBs. There's a difference in power between a voice-centric error-tolerant network and a data broadband connectivity. In this slide, I just show the differences between voice-centric and data-centric infrastructure. But the most important issue here is that a voice-centric network is a one-dimensional network. So with that, if somebody gets a handset and he's supposed to connect on to make a phone call, it's almost trivial. Yeah, it's almost trivial. But if you give somebody a smartphone and he has to start using smartphone to access internet, there are so many different questions that that person has to answer. The first is, for each service, you need an application. And most of us are familiar already. You just go to the internet, you download an application, and use the service. Secondly, of course, you need to search for the right applications. You need to know how to navigate and get the right content and so forth. So it's really that different between voice-centric and broadband networks. The challenges can be categorized in two areas. One is on the access network, which is where users will connect to the network to get services. And the second one is on the backhaul or transport network to connect the various base stations or the various access points. For 2G network, you can have a tower at the edge of the city or the edge of the town and can give coverage over 10, even 15 kilometers. So with one tower, at a strategic location, you can cover the whole town, okay, because you can reach huge distances, 10, 15 kilometers, because it doesn't require a lot of, it requires low power. If you have enough power, it can reach huge distances. This is another example. It's another town called Malaria in Congo. You can see for a 2G or voice-centric network, you have towers at the edge of the town. Most of the town can get voice services, but when it comes to broadband services, it becomes a problem because we have a difference in coverage between voice-centric requiring low power and data or internet requiring high powers to reach huge distances. So what we've done in the past is to carry out propagation measurements. Okay, we carried out propagation measurements in different parts of Tanzania. This will be equivalent to, for civil guys, if you take a soil test, okay? So just test for the propagation situations in different environments to get radio profiles. Once you get these radio profiles, you are able to estimate what will be coverage for voice services, what will be the coverage, expected coverage for broadband services in different areas, and for different traffic, if it's in the flat area or hilly area, or if it's undulating landscape. There are different types of terrain that you want to cover. So we did this in almost 6 different regions, okay, and the result of this was to get what is called scatter plots. Okay, the scatter plots gives you pass loss estimations, and you can take an average of the pass loss to get the average pass loss in specific areas. And this is critical because you can use this to estimate for broadband if you are in a flat area how far you can go, or if you are in a hilly area like Lushoto, Amani, Tanga, or this area here in Usa River, the coverage profiles will be very, very different. So from this, we end up with some radio profiles for different areas, and we used this to estimate what will be the coverage requirements for broadband. And this is one of the information that we use in trying to estimate if you want ubiquity for broadband, what it will take to be there. But the answer will be that it's not just throwing money on the problem. If you just look at investment issues, you will not be able to solve this problem. It's just huge to be solved in just one dimension. That's one of the suggestions that we have. So from the pass loss profiling, you will normally get 3 types of combinations giving you the overall pass loss. You have an average pass loss. You have a component number 2 there, which corresponds to the terrain. If it's a hilly area, if you are receiving behind a building or you are receiving radio behind an obstacle, a hill or something like that, you get additional loss. And the third one is related to mobility. If you are also accessing and connecting to the network, at the same time you have mobility aspects, then you have obviously additional pass loss overall, in overall pass loss estimation. So what you get is, for different areas, you are going to get an average received signal from the base station going to a receiver somewhere. It could be inside a building or outside a building, but this will have the impact from the terrain or the pass loss. That will have a pass loss exponent, which we have marked there with an N. So the signal can be falling very, very quickly because to the power of exponent to the distance. So from the transmitter, if you go away from the transmitter, then suddenly within half a kilometer or 1 kilometer, then you are already out of reach for mobile broadband connectivity. But as the signal goes down, you also speed, you lose connection speed. So you could have a very good connection near a tower, but as you go away from the tower, the connectivity, the throughput you have declines, and it can decline very, very quickly, especially if you are in an hilly environment. So we put that into estimation of the received signal powers. Here we have 2 thresholds. One is the threshold for internet connectivity, from the received signal strength, and the other one is for voice threshold. If you are receiving in line of sight, that is without any obstructions between the transmitter and the receiver, you can easily reach beyond 10 kilometers. So you can do broadband to very long distances if it's a very good connection between the transmitter and the receiver. If it's a flat terrain, then suddenly you are talking of about 4 kilometers for broadband and about 7 kilometers for voice. So already you see the difference there between a voice-centric network and broadband internet connectivity, just by considering pure received signal strength. Here we haven't factored in the fading characteristic, we haven't factored in other impairments. But if it's in very, very hilly area, like Lushoto or Amani in Tanga, those areas, the pulse loss exponent is almost 7, which is very, very high. That results in broadband range of about 1.5 kilometers. Okay, while for voice, a bit more, maybe 2 kilometers or 2.5. So the challenge in connectivity is there. So how many base stations do you have to build, especially for the underserved areas, if your range is 2 kilometers or maximum 5 kilometers? So it's almost difficult to conceive or to consider that you can have an investor who will invest thousands of base stations, broadband base stations, with a coverage of an average of maybe 3 to 5 kilometers, while the population density is somewhere between 100 to 500 people per square kilometer. So the numbers don't match. Okay, so that's why we think that it's not just an investment issue, something else have to be considered as well. So that was the access part. The other part is on the transmission, which is a backhaul. Okay, let us consider you have 2G sites, say from maybe Mtwara to Dar es Salaam. These will normally be chained, okay, along the roads and some spare routes or maybe some spare sites connecting. For voice, you might need maybe 2 or 3 E1s to connect a site. But if we enable now broadband for each of these sites, then suddenly you need at least 10 E1s per site. Now, this will require you to be able to change the whole transmission from Mtwara to Dar es Salaam to accommodate the additional capacity needed to support broadband. So you can see practically it's almost impossible to do that. So there has to be a different approach, how we provide national backbone infrastructure to cater for broadband connectivity. The next slide here shows what has been happening globally. Some countries have taken a different approach. What they've done is to take out completely 2G network and take out completely 3G network and put in a 4G network. Because that is where you could consider that you have the entry point for broadband, mobile broadband. But for our environment, I think we're going to take quite a long time, and we cannot contemplate to take out the whole of 2G network to put there a 4G network. They will have problems with handsets. There will be a lot of complications. Okay, so here is where we need our research to help us understand what should be the deployment strategy, to move us from 2G prevalent network to a broadband, more broadband connectivity and services. Of course, we have our national ICT backbone. So that's a good starting point to build broadband, ubiquitous broadband infrastructure. But here we have some issues. I know there are plans to have more point of presence in many areas to be able to connect additional access points needed to really provide broadband. The current situation is we have very limited point of presence. On average, for example, Morogoro region has only 1 point of presence. Now you can imagine an operator has to build their own IP cloud, and the point of presence is in Morogoro. So there are challenges, which means, in fact, part of what we are investigating is how to improve the backbone network to support ubiquitous mobile broadband. So how do we get broadband everywhere in these countries? So that was the question we started with. The definition, ubiquitous, means present everywhere. So what we need is, in fact, if you have 80% or 90% penetration, that is close to ubiquitous mobile broadband. So to get those numbers, how do we get there? So initial stages yet, but we see that, okay. I'll move towards concluding this presentation. Okay, so we have to be smart on how we get there. Okay, so investment alone, I think, will not be good enough. There are some unique issues as far as the market of Tanzania is concerned. There are some issues on the investment side, including risk for investors. But we think that what will get us there will be innovations in different areas. And the key will be innovations in policy and regulation. I think that will be really key, because whatever you try to do, it has to be within the rules and the regulations of the country. So if we start with innovations in the area of policy and regulations, that can help spur innovations in other areas. Okay, of course, some, like universities, will work on innovations in technology, deployment strategies, product and services, business models. That is also another key issue, innovations in the business model, because this is a completely different market compared to other markets. I will skip this. This just shows some of the complexities in this market, which is the population distribution and the population density. This comparison between developed countries and Tanzania from a market perspective. And then some examples of what should be possible innovations in the area of policy and the regulations. On the regulation side, in fact, we can follow guidelines from ITU, where the ITU recommends collaborative regulation, which means the policy and the regulations have to consider the struggles or the challenges that operators are facing. So from the challenges that the operators are facing, that should inform the type of policy and regulations to be able to help with achieving what we want to achieve, which is ubiquity in terms of broadband connectivity and services. I'm finishing now, the last two slides, I think. Innovations in business models that can, small operators and small companies can help us in this area. So we should encourage small new companies to come on board. When they come in, they are not coming here to compete with the big guys. They are not coming here to compete with Vodacom, Airtel, or Tigo. They are coming here because they've seen niche areas where they can contribute. So there should be, because they're coming here to innovate, there should be support for these new and small operators who want to come in and provide innovations in the local telecom industry. I was also thinking that on the municipalities can also contribute in terms of broadband infrastructure rollout. Some, not all, but some can consider doing that, and it shouldn't be a problem to allow them to do that. Lastly, we need to have example type of applications and services that we can take to those who are not connected yet. We can tell them that if you connect to the internet, these are some of the examples, some of the benefits you are going to get by connecting to the internet. There are people who don't even have ideas what benefits they are going to get once they get online. So we must have maybe a national set of applications that we can say, if you want to go to any area that you have new users, these are the kind of applications you can demonstrate that there are benefits of being online. Okay, I think that will be also very, very useful. And for a summary, from broadband perspective, comparing with other countries, we still have some way to go. because it's a unique market. It's a very unique market in terms of demographics and in terms of market characteristics. So the key there is innovation. We have to innovate in different areas. And I think from our discussions, innovations in the area of policy and regulations and business models. Of course, in the universities, we are doing research and development work. So if we combine all that, that will help us achieve ubiquity in broadband connectivity and services. That's all I have. Thank you. Yes. Thanks.
Thank you very much, Dr. Chitamu and Dr. Masawe, on your paper. The presentation of your paper took slightly longer than was planned. So I'm going to request the next presenters to make it even shorter, maybe 10 minutes, 15 minutes at most. But before I do, I invite them, before I read their CVs and invite them to make the presentation, I would like to request that in case you have a question, just put it down on paper, wave your paper, and someone will come round to collect it, please. Now I have to read, okay. The next paper is going to be presented by Engineer Gevas Lukinga, but it's co-authored by two gentlemen, Engineer Professor G.D. Mrema, who is a professor at the University of Dar es Salaam. He is a PhD from Norwegian University of Science and Technology in Norway, but an MSc from the University of Dar es Salaam, BSc from the same University of Dar es Salaam. He is an associate professor of chemical engineering at the University of Dar es Salaam and consulting. He's also a consulting chemical engineer. He has researched in the fields of thermodynamics, optimization, environmental studies, and utilization of natural resources. He worked with public higher education institutions, including University of Dar es Salaam, MUSE, that is Mkwawa University College of Education, as well as a private institution such as Tobacco. On the other hand, Gevas Lukinga is, I just talked to him, he's a mentee to Professor Mrema. He has a BSc in Chemical and Process Engineering from the University of Dar es Salaam. He is a lubricants and production engineer at Oryx Energies, Tanzania, and also worked as wastewater treatment plant supervisor and chemical warehouse manager at Tanzania Toku Garments. The paper is going to be presented by Gevas Lukinga. Karibu Bwana Lukinga. Dakika 10, 12, 15 umezidisha sana. Karibu.
Yeah.
Good afternoon to everyone. I'm here to present our joint paper going under the title of A Novel Approach for the Utilization of Dar es Salaam City Domestic Waste as a Source of Energy, under the subtheme of Sustainable Energy Development. Just to take you through, this project title concentrates to solve the two problems. Actually, the Dar es Salaam City is the center of most commercial activities in our country. And due to that, have been a challenge with population growth, which further leads to generation of more generation of domestic waste in the city, and also due to the large population, also lead to the increased demand of energy. As a National Bureau of Statistics in 2012 did a statistic for the population of Dar es Salaam, and the population was 4.4 million. And you can see just for this around 80 years, the population was increased to 6.8 million by the rate of 5.5%. So due to this high population, it contributes to domestic waste generation and energy demand. So the title actually concentrates to solve the two problems. First, to help solving this domestic waste generation, how to manage them, and thereafter, how can we solve the energy demand for the city of Dar es Salaam. The two problems of domestic waste and energy demand have a link to our main theme of this conference. We need people to work in our country so as to reach the middle income economy in our country. And also we need industrialization development in our country. But having this domestic waste, which are not being treated well, not collected, and they are produced at increased rate due to population, actually can cause different problems. And actually the domestic waste that is generated in Dar es Salaam, we're going to see thereafter, its composition is highly composed of organic matter. So which, when left untreated, and when it's left uncollected, can cause pollution and other environmental and health diseases, which can thereafter reduce the quality and the quantity of the labor force, which have to contribute to the economic growth of our country. So this study reveals the potential approach, a scientific approach that can address the two cases, to solve the domestic waste problem and also to increase the energy availability in our country. So I will analyze this paper will analyze the different waste to energy approach that can be viable according to the nature of the waste that is available in the domestic waste of Dar es Salaam city. So the three main pathways that we can convert the waste energy, the domestic waste energy into domestic waste into energy. There are thermochemical conversion, biochemical conversion, and the physiochemical conversion. In the thermochemical conversion, actually, we are going to deal with pyrolysis combustion processes, which actually does not relate with type of waste much, because according to the further analysis, which I will share to you later, the domestic waste of Dar es Salaam is composed of high moisture content, which is not feasible for doing combustion processing. And also the second conversion process is biochemical conversion. In this, we're going to do biological conversion and chemical treatment to the waste, either to extract the energy in it or to extract nutrients in it, where we can do either fermentation or biodigestion. And the last one is physiochemical conversion. Actually, this is going to do the change of physical properties and chemical properties of the waste. So here is how our problem lies. Inadequate domestic waste management is going to threaten our ecological environment and the general public health, especially for the 60% of the domestic waste that is left uncollected. And thereafter, the increased energy demand, which is actually caused by the population growth, is going to be another problem if it's not well addressed. And actually, we need much energy so as we can reach the goal of industrialization in Tanzania. As if we need much energy, So we must save the energy we have and increase other more types of energy or forms of energy. So I will utilize the domestic waste that we have to increase the energy matrix of our country. The main objective of this paper was to develop the novel and environmental approach that can produce energy from the domestic waste. And we can attain this objective by doing the following specific objective. First of all, we need to know the composition and the quantity of the domestic waste that is generated in Dar es Salaam daily, monthly, and even yearly, so that we can know how much energy we can take from it, or what type of energy or form of energy we can derive from that waste. Without knowing the composition, it's going to be hard. And the second specific objective, we're going to determine and evaluate alternative possible uses of the waste, and also to select the best approach that we can use this waste and to be useful to us. And also, since we are linking domestic waste as a raw material for energy production, then the first specific objective needs us to determine the relationship between the amount of waste used and the energy produced. Like, if we have this amount of waste, how much quantity of energy can we get out of it? And the last, we need that energy which is environmentally friendly and it can conform with the environmental constraints. So as to attain those objectives, I have the methodology to go through. First of all, the type of data that I'm going to use are most of them secondary data from the data archives and also from the statistical database which are relevant to our topic. And these data are going to be processed and analyzed by using Microsoft Excel, which is the model of 2016, and different equations, so as we can analyze and process the data to get or to attain our objectives. And also the data are going to be presented using pie chart, line chart, and also histogram. So for the case of the domestic waste type composition and quantity, here we have like 7 domestic waste types. When I say domestic waste, I actually mean the waste that we are generating in our premises, like leftover foods, garbages that we are creating in our home when we are doing home activities like cooking and whatever. So these are the types of waste that are within the domestic waste. And we can see 74% of the waste, of the domestic waste, is composed of the organic material. So this gives us a clear picture. The large quantity or proportion that we're going to use from the domestic waste is organic material. And for the second specific objective, we're going to see the population and the waste quantity that are generated in Dar es Salaam from 2012 to 2020. As you can see from the bar, yellow bars are representing the waste quantity. The waste quantity keep increasing year to year. From 2012 to 2020, we have the highest waste quantity that is generated. So it means that every year we go, the more the waste is generated, which means the population is increasing, the domestic waste are generated in higher quantities, which actually need us to take actions through it so as we can solve those problems I've elaborated earlier. And also, from the blue line graph, it tried to show the population of Dar es Salaam for this case study. As you can see, it was 4.4 million in 2012 and keep on increasing to 6.8 in 2020. So the two parameters, that is population and the waste quantity, are increasing with time. I won't take you through much of the calculation, but after doing calculation based on the data of population number and also the quantity of waste that a human being can generate in one day, we come up with what type of the vessels that can deal with this waste to convert them into energy. And from the literature review, since you have seen the amount of the domestic waste generated was highly composed of the organic matter, and during those three conversion process or conversion approaches that we can convert this domestic waste into energy, we have seen the second approach, that was biochemical conversion, was actually related to the type of waste which is composed highly of organic matter, because it's going to use the organic content of the waste to change it into energy. So for our case, to produce biogas was the selected form of energy that we can exploit highly from this type of domestic waste as based from the composition we have. So in order to produce biogas, we need a vessel or a reactor where we can convert this domestic waste, or where we can exploit this organic part of the waste to produce that energy. So the calculation was made based on 1 year. So for the whole year, if we collect all the domestic waste, we can produce energy for 1 year. This was a vessel requirement. It's around 500 m3. If we have to produce the energy at one location, but still we can split it into different locations. For example, into different 5 municipalities that we have in Dar es Salaam, but collectively the volume of the vessel should be around 500 m3. So from this vessel, then we can inject those domestic wastes and able to get biogas from this reactor. So the biogas that can be produced per particular day of the waste that we are going to inject from the vessel is around 600,000 m3 biogas per day. And biogas actually is a gas which is being composed of different components, but it's highly composed of carbon dioxide and methane. Methane is around 70%, carbon dioxide is around 30%, and the other constituent of gases, they can take around to 3 to 4%. So in the biogas, we can use it as it is, as the gas, as a source of fuel, or we can upgrade it further by removing the unwanted gases, especially carbon dioxide, and attain this methane, which we can use it have high heating value more than the biogas. So if we have to upgrade the biogas to get the methane, actually the volume is going to be reduced to 460,000 m3 of methane per day. So here is actually, I want to show you how this biogas can be used or can be compared to other different sources, fuel sources. And biogas, 1 m3 of biogas is approximated to have around 6 kilowatts of power. So as you can see here, we can produce, based on the quantity of the domestic waste that we're generating daily in Dar es Salaam, we can produce around 657,000 m3 of biogas per day. So just 1 m3 is equivalent to 6 kilowatt hour. So you can see how many kilowatt hour we can generate from this quantity that daily that we can get from the biogas that can be generated in daily basis from the city of Dar es Salaam. Apart from the calorific value that is equivalent to 6 kilowatt hour, we are also familiar with other fuel sources like diesel, kerosene, wood, propane, natural gas, LPG, and etc. So I can also show the equivalent of how these other fuel gases are equivalent to 1 m3 of biogas. As you can see, 0.5 kilogram of kerosene or diesel is equivalent to 1 m3 of biogas, which means 1 m3 biogas is equivalent to 0.5 kilogram of kerosene or diesel. Or we can compare it with whatever, like natural gas. 0.6 m3 of natural gas is equivalent to 1 m3 of natural gas, which means from the natural gas, if we take out carbon dioxide, 1 m3 of natural gas is going to be approximately equal to 1 m3 of natural gas. As we know, natural gas is also more than 95% composed of methane. So if we remove carbon dioxide from natural gas, the two gases are going to be equivalent. So by concluding, since 1 kilowatt hour of, 6 kilowatt hour are equivalent to 1 m3 of biogas, which we can compare from the volume of biogas that we're going to get in daily basis from the city of Dar es Salaam. It's like more than 3.9 million kilowatt hour of energy are going to be produced in daily basis. if all the waste, domestic waste, is to be used to produce biogas, and it's equivalent to 164 megawatts in daily basis. And we know that the current national power generation capacity is around 1,500 megawatts. So mathematically, this 164 megawatts is almost 11% of this total quantity of the power that we have in our country. So utilization of domestic waste from Dar es Salaam to produce power, it can add this 164 megawatts to the national grid. And having attained this kind of energy, to add it to the energy matrix of our city, or generally to our country, it can help us increase the to increase the power, and also to save other types of energy to direct them into the industrial development. And this will take us through the development which we are looking for to maintain and to develop in the second stage of economy. So, by doing so, we'll enhance sustainable energy development in the city of Dar es Salaam, and if it be applied to other regions, it can be also the sustainable energy development for the whole country. Having said that, all the research objectives have been achieved, and the best way of utilizing biogas in our country is by using it as a heat energy for cooking stove. And if you prefer to upgrade it by removing carbon dioxide, it can be used for electricity production and add those power I've calculated for you to our national grid. This is the end of presentation. Thank you for your attention.
Thank you very much, Engineer Lukinga and Professor Mrema, for your presentation. Once more, if you have any questions, put it down, wave your paper. Preferably also put down your either email address or telephone number in case the presenters cannot respond to all questions. They can contact you later on with their responses. Ladies and gentlemen, the next paper is on conversion of non-coking coal to metallurgical coke for iron making in a blast furnace for improving iron industry in Tanzania. And the paper is going to be presented by Dr. Hiji, but it's co-authored by himself, somebody Mde, Mr. or Mrs. Mde, and Semboja. The presenter, Dr. Hiji, is the head of department of mining and mineral processing at the University of Dodoma. He has a PhD in metallurgy engineering, and he's a researcher in utilization of coal in Tanzania. Dr. Morris F. Hiji, karibu sana. Again, ukiweza kutumia dakika chache itatupunguzia muda tuweze kukatch up na muda tuliopoteza. Karibu sana. Is your present? Is it already here? Okay, quickly please.
Good afternoon. I'm Dr. Morris Hiji from Department of Mining and Mineral Processing of University of Dodoma. I'm here to present the research title, Converting Non-Coking Coal to Metallurgical Coke for Iron Making in a Blast Furnace for Improving Iron Industry in Tanzania. Okay, thank you. Yeah, I'm presenting the work of researchers from University of Dodoma, and our target at this work, it is to prepare utility that will enable us to convert iron to steel. Are we together? Our intention is to prepare utility that will enable us to convert iron to steel. You can see now the issue of scrapers. The major source of steel in Tanzania now is scrapers, and that cannot suffice the requirement needed. So in this work, we are trying to see, can we prepare utility, and in future, can we convert the huge amount of iron that we have to steel? Now you can see now, to the moment, the production of coal worldwide is around 5 billion tons per year, and 57% is used for electricity generation. In addition, 25% is used in converting metallurgical coke from iron to steel. This is where our future target. And for Tanzania, our country is very rich, has got around 5 billion tons of coal, and we are producing around 500 tons per year. And our coal is categorized in a rank of subbituminous to bituminous. Now, the government has long wanted to establish an integrated iron and steel mill in Liganga and in Njombe. That is not yet working. However, the blast furnace remains the principal process unit for iron production in industrialized world, and use coke from coking coal. So our target is, can we convert the Tanzania coal to coke so that it can be used in iron production? I explained that the powerhouse for iron production is blast furnace, which puts as a requirement for metallurgical coke. So this research assess the technology of converting the available coal in Tanzania to metallurgical coal for blast furnace, so that we can meet the local market and even the international market. The main objective of this work to produce coke from non-coking coal for blast furnace iron making. And the specific objective number one is to characterize the current production of coal from Ngaka. And next, we want to produce residue char that is non-coking. And the next is how can we convert that char to the coke. And the final one is how to characterize and assess the produced coke. So one is the methodology, the sample collection. You can see the sample collection and the sample preparation. Then the next one is to characterize the coal from Ngaka, and we are going to use proximate analysis and ultimate analysis. Then after doing that, the next objective is to produce the char. After producing the char, we are going to mix the char and the binder to produce the coke. And the final one will be to characterize and to assess the produced coke. Now, the results from the first objective, you can see that the approximate analysis result from our call from GACA and the ultimate analysis. Now, the approximate and the ultimate property of call found in GACA show that our call is ranging from the rank of butymous to subbutymous. This means that this call is non-coking and it cannot be directly used for blast furnace for iron making. It needs some conversion to coking quality. That is the objective number 1. Then objective number 2 is after obtaining the char, is to mix the char with the binders. Now here you can see that the response results from mixing that we obtained 2 best run, number 1, number 2. Then you can see that number 1, the binder is 30% and the coal is 70, and number 2 is 47, 49 to 51. Then the characteristic for fixed carbon and ash percent are good. However, for number 2, which it seems much better compared with number 1, has got a problem in has got problem in SI percent. That you can see that 7.7 and 6.7 and 6.14. That one is a problem. However, the fixed carbon and the ash composition for number 2 are good. The SI percent, that one, for run number 1, 6.7 is not good enough for making that coke. Then the conclusion is that the characterization of coal from GACA has shown that it falls in a subbutymous and butymous coal category, which is generally non-coking. Then we need to convert it to coking characteristic, and among the best mixing is 30 to 70 using sawdust binder. That is the end of presentation. Thank you.
Thank you very much, Dr. Hiji. Looks like we are stuck with this microphone only, or is that not the case? Because mine is not working. I think the presenters cannot respond to questions from where they are sitting, so they'll have to come up to this microphone. Okay, we have concluded the presentations. I'm going to request, we have received questions and I've distributed some of these to the presenters. And I'm going to request Dr. Chitamu and Dr. Libe Masawe to respond to the questions as far as they can. For those responses that they cannot, or they feel they need to have one-to-one discussions with the persons who raise the questions, then they are welcome to do so. So who's to start? Yes, Dr. Masawe.
Thank you, Chair. Good afternoon, everybody. Okay, I'll start with a question from Mtalingie. He's asking, how are you engaging stakeholders like TCRA, UCSAF, and so on, in trying to solve the broadband access challenge? Actually, as mentioned by Dr. Chitamu, we have weekly research seminars at our department, and we have been inviting different people of course, at their personal capacity, as to come and share their experience and their knowledge on this broadband issue. We have invited people from TCRA, we have a member from UCSAF, we have a member from different mobile network operators. So as we're starting this research, just to get their personal opinion, and then we'll then move to more official way. Another question is, he's asking, the government has reduced the tax in importing of mobile device and handsets. And, hello? So he's asking, do you think this will help to promote the broadband penetration in the country? Okay, the answer is yes. However, availability or affordability of this mobile handset is not the only hindrance in the broadband. There are other challenges, as it was mentioned by my colleague. There's a lack of broadband infrastructure, the digital skills, the local content, the type of content which will really make someone to use the broadband. So yes, it will, but it will not eliminate all of it. And the second question is there any research which has been done so far to evaluate if this, which is a reduction in the tax in importation of mobile devices, has encouraged the availability of mobile phone and devices? Okay, this is something we are starting. We're working on it. We have not done that yet, but it is in our plan to do it. Okay, so I will invite my colleague to continue with the rest.
Okay, thanks, Libe. Let me comment on just a few questions, additional questions, very quickly. There was a question from Albert Richard regarding initiatives through UCSAF, to change 2G sites to 3G and 4G sites. And he's asking, do you think switching off 2G networks can be a nearby solution? Maybe just a general comment that first, when you have so many different networks, it confuses the market. Okay, so I think if we have a strategy just to take out 2G and maybe have latest of 3G and 4G, or even just 4G, in the long term, that will save us better. That's a personal feeling. But if there are all these ad hoc deployments without a proper what I would call this, proper strategy of how we want to get to broadband, that can take us longer to get there. So it's better to have a holistic view of how we want to get there, and then through that, maybe we can get somewhere. Okay, there's another question from Nicholas, Engineer Nicholas. He's asking first, is 80% by 2025 realistic? I think we always hope for the best. So I think we just have to work towards that target and see by 2025 how far we've gone. Another question was regarding the broadband issues via backbone issues via ICT backbone. I think this is a business model issue. So we need really to address if that is hindering progress towards ubiquity, then we need to address it. Whether monopoly by national ICT backbone is good enough for us to get there, or there have to be other ways of doing it. But I think this is a purely business model issue. Normally, when you have different suppliers and so forth, that will also add to the overall cost. And for this country, we need to work towards driving down the cost of broadband service provision. What about TRC? When TRC also deploy fiber, it becomes very similar to national ICT backbone. It becomes one of the business model coming into the telecom side. So I think we have to look at it holistically and see if that will help us drive down the cost of telecom service provision. Lastly, this issue on Tarula, okay, right-of-ways issues and so forth. This is is increasing the cost of fiber deployments, and is highest in Africa at present. Again, this is a business model issues. I think TCRA can drive this from the policy and regulatory issues from that side, and see if they sit together with the operators, they can get somewhere where these government bodies can help us drive down the cost of broadband service provision. That's all I have for this.
Thank you very much, Dr. Chitamu and Dr. Masawe. I think it's time now we heard from Professor Mrema or Mr. Lukinja, or both. I don't know which is which. Is it both? Is it one? And who? Both? Okay, karibu. Mara moja. To the point.
Good evening once again. I've received several questions, but the first question is asking, is the problem lack of domestic waste treatment methods or improper correction in sorting mechanisms? Answer to this question is yes. If we don't have proper domestic waste treatment and correction methods, we have problems. As I elaborated before, this waste is composed highly of organic matter, and as we know, the organic matter is easy to be decomposed and can lead to availability of bacteria in the society. And once these bacteria are available in society, other pandemic diseases like cholera and other diseases will be available to the society, and hence we can be lacking of labor forces in our country. And without labor forces, we are going to lower productivity and actually affecting our economy. So it's a problem. The second question is, how cheap is the production of energy from domestic waste compared to other sources of energy? This question was asked by Engineer Fabian. Actually, if we concentrate only on the matter of energy, we can say it's not cheap compared to some other source of energy. But since we need to address also the issue of domestic waste, that's why this was the option regarding the composition of the domestic waste we have. Another question is asking, how do you intend to sort domestic waste with organic nature, as I'm aware of the city dump like Pugu, all waste are dumped together? This question was asked by Lehema Mahundi. Actually, when maybe the government is ready to take over this project, the thing is we just create value on the waste. Like if you promote people to do segregation of the waste and you take it at a low cost, because now people, they should pay for the waste to be collected. That's why many other people, especially in the restaurant, they throw the waste in different areas on their own because they need to escape this payment method. And they're going to throw this waste into the areas which are not selected for the waste collection. So if you create a value on this waste, as per 1 kilogram, someone will be paid this, like those plastic bottles. Actually, the waste will be segregated, I'm telling you. So this is already answered. Another question is, where did you get your reactor volume of 531,000 m3? What are your basis or references? Actually, due to the time frame, I could not show all the calculations, but the basis of to get this volume, first, I considered the volume or the quantity of waste that is generated in Dar es Salaam in daily basis. And I made several assumptions. Since that waste, we need to deal with the organic part. So the reactor is working with a solvent. So we actually mix the waste with water with a ratio of 1:2. If the waste is like 10 kilogram, we add another 20 kilogram of water. So the assumption I made is hydraulic retention time is 30 days for the waste inside the reactor, and also 1 kilogram of the waste is equivalent to 1 liter. And the total solid content is 20% of the organic waste. In the organic waste, we have total solid content and other content. So the total solid content is 20% of the organic waste or domestic waste. And also, the type or the thing that is going to produce biogas is not all the organic waste, only the volatile solid content of the waste. So I also made the assumption that the volatile solid content of the waste is 80% of the total solid content. And 25% of the reactor volume is going to use for gas storage, while 75% is going to use to treat those waste. And also the low feedstock, which is actually the domestic waste, will be diluted at the ratio of 1:2. Basing of this assumption and the formulas, we can arrive to this volume. But as we know, this is a huge volume. We cannot build it in one area because it can take a diameter of around 15 meters and a height of around 10 meters, which is huge. So that's why I suggested it can be built in different cities, in different municipalities, which we can build 5 reactors or 5 vessels of around 1 million m cube, which is slightly okay than building at only one. I mean building this reactor at the one place. So 500,000 m cube is huge. So we can break it to 5 reactors at different location, and we can build them at around 100,000 m cube, which is approximate to 1 million liters. And another question is, biogas was started being used in Tanzania for around 2 decades, not now, but was not discovered or used to handle waste generated in our society. Is it true or not? And if it's true, then why? Of course, biogas was started before, but most of the project that was dealing with biogas from the cow dung, especially, there was generating biogas in a premises case. It means every house has to build its reactor. If it's 5-liter reactor or 20-liter reactor, every house. That's why it was not able to manage this, because people, they can really quickly run to use wood, charcoal, and escaping these things to manage the reactor. Actually, reactor is a chemical vessel. It's need to manage with knowledge, with people who are professionals, so they can know the amount of bacteria in the reactor, the amount of waste, the space of gas, to make sure that the process is carried out well. That's why if it's been done in naval house, that's why it was not being able to be accomplished. That's why it just started and stopped. Another last question is, the figures appear to be very promising in terms of power generation, that is 164 megawatts. What is required in terms of financing of the project? Have you submitted your proposal to TANESCO? And what are their response to the proposal? Actually, this project is, we didn't did it for so long. It's 7 months now. So we did not submitted any proposal to TANESCO yet. Maybe if we discuss with my co-author, then we can submit this proposal. But see, in terms of financing the project, actually, since it's dealing with municipality and all the city of Dar es Salaam, the government must be engaged in TANESCO so that it can be financed. It's a huge project, actually. As I've said before, it contributes for more than 10% of the national grid. The other question my colleague will come to continue with. Thank you.
Good afternoon. There was another question directed to us. Are skilled human resources available? Unfortunately, the engineer did not indicate his name, but He was asking, are skilled human resources available locally to convert the waste product into biogas? Our answer is yes. Yes. We have Temdo. Temdo, they are extremely experienced, but remember that in East Africa, Rwanda is on the forefront. And actually, Rwanda took technology from us, and also they took some of the trainers from Tanzania to train them. And now they are pioneers, kind of. Sisi tumetengeneza plani, wao wameimplement. So there's no problem of skilled labor. The other question was, is the technology available locally to convert biogas into electric power? And we say, at the moment, no. It's this is not exception for Tanzania, but for many developing countries, this is still, I would say, largely at a pilot or experimental stage. But for developed countries like Germany, Netherlands, and many of the other developed countries, they are at this level, converting biogas to electrical power and connecting to the national grid. The other question was, how much financial resources is needed to invest on generating 164 megawatts from waste in Dar? Our study did not engage on economics of the plant. Our interest was on the feasibility of the plant. Is this thing feasible? Will it be sustainable? And the next stage, maybe it will be on economics and more engineering design if there is need, and so on and so forth. The other question was, how is the sustainability of such waste as raw material to produce 164 megawatts? I would say yes. We are convinced that it is sustainable. And the reason is, if we look at the inputs, what is required to generate sufficient municipal solid waste, they're kind of met. One is that you require a continuing population increase. And I think my colleague has showed you that the curve is increasing. A few years ago, we were at 4 million, now we are 6.8, and it's still increasing. The other is urbanization, and we all agree that there is a very serious urbanization to and flow to Dar es Salaam. The third is economic growth, and we said Dar es Salaam is the center of business in Tanzania, so this will continually increase. And the other one is the lifetime actually lowered or reduced lifetime of products and packaging materials. And we are all witnesses that as time goes on, many of our products have lower lifetimes, but also the packaging materials. And we hope that sicknesses, the impending sicknesses, they are not going to wipe us out. They are not going to reduce our population. They are not going to reduce our economic growth, that we are convinced. So we think that this is sustainable. And the last question, also the engineer who put up this question did not indicate his or her name, but he said, please, I'm interested to know from your study, have you come across any relevant case study where any society or nation has employed that knowledge of conversion of waste to energy successfully and being able to add the power to the national grid? Yes, our answer is yes. And we mentioned Germany, we mentioned Netherlands, and I think GTZ is currently assisting many nations to connect the biogas produced to produce electricity and connect it to the national grid. But otherwise, in many of the developing countries, the trend is to use the gas for heating and for lamp at home and for simple kitchen stoves. But the developed countries, they have gone past this stage. They are connecting it to, they are producing electricity from biogas and connecting it to the national grid, as well as using it for municipal heating of water, especially countries where they experience winter. Many of the central heating system of water is done by energy which is produced from biogas. Thank you.
Thank you very much, Professor Mrema and your colleague. It's now my pleasure to invite Dr. Morris Hiji to respond to the questions. We've had an average of more than 10 questions per presentation, so bear with us, please, but summarize as much as possible, please.
Okay. Good afternoon again. Yeah, I've got 4 major questions, so I will try to answer. The number 1, Roman 1, how does our coal can meet coking qualities? And do we already use our coal as coking? For Roman 1, as I said, the rank of Tanzania coal is semi-bituminous to bituminous, so does not have the quality of coking. However, we can convert it to char and then mix with binders where we can get the characteristic needed. Roman 2, do we already use our coal as coking? As I mentioned, the major use of Tanzania coal is fuel, particularly in our cement industry. And you can see the steel industry depend on scrapers, which is less than 50% of the requirement. Labda niseme tu kwa Kiswahili. Ukisahau chuma chako mahali popote utakikuta. Ukiwa unajenga daraja, ukifanya uzembe wowote wanaiba lile daraja kabla hujafanya chochote. Kwa sababu the steel industry is getting less than 50% of raw material needed. Our idea is to start to think, can we convert our iron to steel so that it can support our steel industry? That's the question number 1. Question number 2, it has always been proclaimed coal processing produces huge quantity of carbon dioxide gas, which poses danger to the environment and it leads to ozone depletion. How can you propose your coal in the midst of such environmental pressure caused by coal processing? As I said, currently 5 billion of tons of coal is produced and 57% is used for electricity production. The leading country is China and America. So we don't tell the people the truth. The major source of electricity is from coal. And if you remember, the American even refused to sign that Kyoto Protocol because they are using coal. If with the police, we are using our source of electricity from gas, Songo gas and Central. That could be better used for domestic purpose. What we are supposed to put effort in production of the coal and use that coal for production of electricity. The generator that used coal is more feasible than gas. If you want to buy even generator, you can see the price of generator from petrol and from diesel. The source of fuel to use for generator also determine the price of the generator and the feasibility. So this is more politics. If you want to tell the truth, we go back and find a way we can use our coal. Another question, do we have anywhere in Tanzania that we have blast furnace? And is there any extraction of iron? Yeah, there is extraction of iron. Even here in Dodoma, Dangote is collecting the iron from Dodoma. There is, but the idea is to start to convert the iron to steel. This is ongoing work from University of Dodoma. We reported it this time, and we wish next year to report again the progress of this work. And the last question is is what are the advantage of metallurgical coke, non-coking. I explained that the metallurgical coke is primarily used in blast furnace for converting iron to steel, and non-coking is what we are using now for coal in Tanzania. Major use is for fuel. Thank you.
Asante sana kwa majibu yako na yalikuwa mafupi, to the point. Kabla sijamaliza, kuna swali nimepokea hapa kutoka kwa Engineer John Kaliwa. Linahusu SGR. Nitalipeleka kwa secretariat ili uweze kupata jibu kupitia either kwa simu au email kama ulivyoeleza. Nipende kuwashukuru sana presenters, na baada ya kujibu maswali ingawa inawezekana swali lako halikujibiwa kama ulivyotaka au ulivyotarajia, au una maswali mengine, niwakumbushe kwamba contact addresses either telephone or emails ziko kwenye proceedings. Otherwise, nadhani tumemaliza session hii. Naomba tuwapigie makofi presenters wetu. Asanteni sana na washukuru sana.
Tafadhali naomba tena makofi mengine kwa Professor Lema na timu yake. Nashukuru sana. They've been fair on our theme on how we can use the principles and phenomena in engineering so as to boost our technology and to get into the middle income. Now I want to make some few announcements. I hope you know that we will have a technical tour on Saturday. Tutaenda Tanform, kwa naomba jamani tafadhali tuonane na wenzetu pale kwenye booth ya IET. Pamoja na hayo, kutakuwepo kuna National Park visit, kutakuwepo kuna trip ya kwenda Serengeti, Ngorongoro pamoja na Tarangire. Kwa ajili ya kuchagua slot ambayo tutaipenda, tafadhali naomba kuna wajumbe wako pale kwenye booth ya IET. Kingine kikubwa zaidi, tukimaliza session inayofuata tutakuwepo tuna cocktail ambayo inafanyika AICC, na wote kwa umoja wetu ni networking time. Tumekuja mpaka huku, tujaonana siku nyingi, tunafahamiana. Kutakuwepo kuna logistics. Tukimaliza hii session ya mwisho, mjumbe mmoja kwenye kamati atatoa logistics. Kutakuwepo kuna shuttles au wengine ambao tayari tuko mjini, tutapeana ni kuanzia saa 12. With that note, now can I please welcome Engineer Deo Mugishagwe. Mengi kwa Engineer Deo tafadhali. Engineer Deo is a president of ASSET, Association of Consulting Engineers Tanzania. He's having masters in construction engineering and management from University of West Indies. He's having bachelor in civil engineering from University of Dar es Salaam. Yeye ni structural engineer mkubwa sana wale wa Kongwe. Vile ni council member wa hii bodi yetu wa IET. Tafadhali mengi kwa Engineer Mugishagwe. Asante. Na session ambayo atatusaidia kumoderate ambayo itakuwa ni session yetu ya mwisho, na I hope you try to manage is coordinating a doctor. Anaitwa Dr. Avitas Muhambiko Mutalemwa, anatoka Mount Meru Regional Hospital. Tafadhali naomba mengi kwa ajili ya doctor. Karibu. Yeye yuko pale emergency department na atatugeia issues about non-communicable diseases. Asante, karibu.
Good afternoon, ladies and gentlemen. We have a session which is cross-cutting issues, and I would wish your attention on the last session before you go and juggle your drinks around the ACC area. So, give us your attention for the good presentation which we are expected to receive just now on non-communicable diseases, which will be presented by Dr. Avitus Mabuki. Dr. Mabuki, welcome. And if you have any questions, please write them down and so that we can collect them from you while the session is going on. Thank you.
Good evening, everyone. As I am introduced, I'm Dr. Avitus from Montemero Regional Hospital, working at EMD department. I'll take you through on non-communicable disease, particularly hypertension, and overview of COVID-19 disease. And that will be our outline. To start with, hypertension, it is an abnormal elevation in blood pressure from within normal. As we know, physiologically, the heart of the human being pumps the blood pressure, pumps the blood to various organs in the body. And there is a blood pressure required for the heart to pump the blood so that each organ in the body can be supplied with enough blood. But also, when the heart is not pumping blood, it means when the heart is being filled with the blood, there is a required pressure which is required. Take home note, not every raised BP pressure means that you are diseased. Sometimes the blood pressure can rise to compensate due to normal physiological body activities. For example, during exercises, for example, during stress or strong emotions. The normal blood pressure in a normal human being, it has, when we say there is systolic blood pressure and diastolic blood pressure. The systolic blood pressure, we mean it is a pressure when the heart is pumping blood throughout the body. That is systolic blood pressure. And the normal range should be 120 to 139 millimeter of mercury. And we have the diastolic pressure. The diastolic pressure, it is a pressure when the heart is being filled with the blood from the lungs so that it can push the blood to the body. So the normal blood pressure when the heart is being filled, also called diastolic pressure, it is 80 to 89. So within those limits, it means you have a normal blood pressure. Now, when it comes, your systolic blood pressure, I mean the pumping blood pressure of the blood throughout the body is above 140 to 149. This is now hypertension. And it is classified as hypertension grade 1. And this is mostly not very severe, and you cannot even detect it in a normal way until when you move to grade 3 or 2. For grade 2, it means when the pumping blood pressure is 160 to 179. And the diastolic pressure 100 to 109. From grade 2 and the BP above 180, it is grade 3. In other ways, grade 3, we call it hypertensive emergence. This patient at any time t can rupture the blood vessels of the brain and it can go to bleeding within the brain, also known as hemorrhagic stroke. So when the BP is above 180 systolic and diastolic above 110, it is an emergency, and this require different medical practitioners to come and give an intervention. We're gonna say on the risk factors. Most of the risk factors which can lead us to have hypertension are classified in two groups. We have the modified risk factors and the non-modified risk factors. The modified risk factors, these are the behaviors or activities which can be changed to maintain the blood pressure. And non-modified, this cannot be changed. Example of non-modified behaviors or risk factors. One is age. We cannot change your age so that to have a normal blood pressure. When you have 60 years and I am 29 years old or I am 15, the blood pressure will change depending to age. So the elderly ones, their blood pressure, it can, once the blood pressure is due to age, we cannot change that because age, it is not a modified risk factor. But also the other non-modified risk factor, we have sex. The blood pressure also varies depending on sex, male and female. And it is more said that the male have high risk of blood pressure compared to female. This is due to their daily activities and how they live in normal life. But also the other risk factor, which is non-modified, we have affinity. If you are the black and whites. So for the black ones, they have high risk of hypertension compared to whites. So now we come to modified risk factors. As you can see on the pictures, those are some of the modified risk factors. To start with, we have the obesity, as you can see here. Obesity, it means the ratio of the body weight and height is not corresponding. Thus, you create the high mass in your body, and so our heart, as God created the heart cannot let you die because of your increasing body mass. So there is the normal physiological process whereby the body will try to compensate for the increased body mass to be perfused with the blood. So the high obesity or the high body weight, so the heart will try to increase the pumping capacity so as can perfuse your increased mass. By so doing, the heart now is doing an extra work, which can also later will lead to other complications which we shall see. So by doing other work, it means the heart now has to increase the pressure. By doing the pressure, is now leading you to hypertension. But also we have smoking. Smoking also leads to hypertension because in a cigarette there is a chemical which leads to vasoconstriction. It makes the blood vessels narrowed. When the blood vessels are narrowed, it means it gives the hard work to the heart to pump blood to other parts of the body. So the heart has to do the work of increasing blood pressure so that it can perfuse all the organs in the body. But also for the patient who has diabetes mellitus, kisukari. So once you have kisukari, there is a tendency of accumulation of the glucose plaques in the blood vessels, and this they make the hardening of the blood vessels, so the blood vessel cannot expand due to in order to compensate. So as the result, the blood vessels also will be shrinking and thus lead to hypertension. Also, if you are taking alcohol, alcoholic is also one of the risk factors. Although alcohol is taken as a vasodilator, in some literatures they say once you take a little amount of alcohol, you can facilitate to vasodilate the blood vessels and hence facilitate the activity of the heart to be low. But the chronic use of alcohol, more than 751 mils per day of alcohol, will also do the vice versa. They will go and vasoconstrict the blood vessels and hence increase the blood pressure. But also, those are the modified risk factors. So also we have the exercise. For those who do not do exercise, they have the sedentary life. It is also a risk factor. As you can do here, most of our works, it is an office work. We stay in the office most of the time rather than moving around. It is a risk factor for you to accumulate the cholesterol in the blood vessels. And this, as time goes, they are going to narrow the diameter of the blood vessels and hence give the heart to the heart to pump blood and hence increase the blood pressure. We have the clinical presentation. Mostly hypertension, it is not diagnosed early. We call it a silent killer disease. The patient will come to the hospital when he is on grade 3 or grade 2. I mean the blood pressure above 180 or 170. But the blood pressure of 140, 150, normally there is no obvious clinical feature. So that's why we normally get patients in a critical stage. We see the patient with a complication of hypertension. And you can be on the good safe side when you normally do the health checkup. By so doing, you will determine your grade of blood pressure, and if it is in grade 1, it is easily managed by life modification stage. But once you don't have any habit of doing checkup, so you will find yourself that you are okay, but once you take the measurement, you find your blood pressure is high, and you start the pharmacological instead of lifestyle modification. So these are the features. When you feel headache, a severe headache means that the blood pressure in the small veins in the brain, there is increased blood pressure, and this will make you feel severe headache. And the more headache, it is more of the two types. You can either have the frontal headache or the suboccipital headache. Also, we have the blurred vision. This is unable to see clearly. It means the blood vessels supplying the blood to the eyes, when they get high blood pressure, they don't supply well the eyes, and hence you don't see properly. It is called blurred vision. Unaona kama mawingu hivi. Also, sometimes from nowhere you can start nausea and vomiting. Unakuwa na kichefuchefu na unatapika without any reason. This seems that in the brain there is an increase of pressure compressing the part of the brain responsible for this part, and hence una present in nausea and vomiting without original source. Also, we have epistasis. Epistasis, it is breeding per nose. Unakuwa una breed damu kutoka puani without any reason. You are here seated, unfortunately unaanza kutoka na damu puani. This signifies that the high blood pressure in the vessels in the nose have ruptured due to high blood pressure. Also, there is fatigue or confusion. Confusion, it is a presentation of hypertensive emergence. Once your blood pressure is above 180, you will present with confusion. And from nowhere to the relatives or people around you, they will not understand why are you confused. Maybe they will think maybe you have been bewitched or something else. While your BP is high, because it is a silent disease. So you just from nowhere you start being confused. You come to the hospital, the BP is 120, is 180, 200, which is very severe and can easily lead to an death. But also we have the chest pain. Most of the patients, most of the people, they feel this problem. You can feel the chest pain. It comes for 1 minute, then it goes around the heart. Then some people do ignore this. Never ignore the pain around the heart. This signifies that the blood vessels in the heart, they are not getting enough blood. So, by so doing, the decrease in oxygen in the heart muscles will produce some chemicals which lead to pain. But also the constriction of the blood vessels of the heart. And the heart is pumping, trying to perfuse the heart. This also will cause pain. And these are the cause, or you can say the immediate cause for people with hypertension. Chest pain, without any reason, go and see the doctor. Also, we have the lower limb edema, irregular heartbeats, and syncope. There are so many people who normally experience the heartbeats. In normal individual, at least you should not hear your heartbeats by your ears, unless maybe it's due to exercise or whatever. But once you start hearing by your ears, the heart is pumping. It means the heart is doing an extra work for you to survive. So it is also called the palpitation. But also we have the syncope and the fainting. So you can, for this, you will never have all these symptoms. You can have only one or two symptoms. So why do we treat hypertension? We treat hypertension because it can lead to ischemic heart disease and heart failure. Because once the blood pressure increases, it means it is a mechanism for the heart to compensate. Now, it will reach a time that the heart can no longer compensate or no longer assisting you. As the result, you will present with the signs and symptoms of heart failure. And once you have the heart failure, it means now we treat you, yani tunasema kwamba kitaalam tunasaidia kuongeza siku, because the heart is already failed. Kwa hiyo tunakuwa tunaongeza siku, lakini the life expectancy of you inakuwa undetermined. Also, you can have stroke and vesicular encephalopathy. Vesicular encephalopathy, it is the nickname of confusion. Stroke, it is due to the rupture of the blood vessels in the brain due to high pressure. So you present with stroke. And for the stroke, we present with the loss of weakness and power of the body parts. Kwa hiyo mtu utaona mkono na mguu ghafla umeacha kufanya kazi, huwezi kushika kitu, huwezi kutembea, kama vile umeshikwa ganzi. It means the brain parts supplying those organs imekuwa damaged due to high blood pressure. Also, you can have the kidney disease, which is chronic and retinopathy because of the rupture of the blood supplying the eyes. So as I said, the management of hypertension, it is a lifestyle modification and pharmacological. But we normally advise on the lifestyle modification. Kwa hiyo once tukimpata mgonjwa mwenye high blood pressure, kwanza tunakuadvise on the lifestyle modification. It means tunaangalia among the risk factors which are causing hypertension, where are you? Within those risk factors, you will be advised, and we shall give you at least 3 months to observe. So once you do the lifestyle modification and you adhere to those, and we do the BP checkup, still is high, now we decide to start you on a pharmacological treatment. But you will be started on a pharmacological treatment when you will be diagnosed to have hypertension grade 2. Una systolic blood pressure inaanzia 160 na kuendelea. Immediately you start you on anti-hypertensive drugs to exclude other causes of BP like stress and whatever. And pharmacological treatment hiyo inaanza kwa daktari kulingana na anavyo mwasesi mgonjwa. Now, let's have an overview on the COVID-19. As you can see there, we have the picture of the coronavirus. The COVID-19, it is the short term of the coronavirus disease 2019. And a corona is a group of the virus which are responsible for causing the severe common cold and the severe upper respiratory tract infection. It means this virus mostly affects from the nose up to the lungs. And this disease, it is caused by the virus which is called severe acute respiratory syndrome (COV-2). This is a virus which causes COVID-19 or coronavirus disease. So the coronavirus disease is caused by virus which is called severe acute respiratory syndrome (COV-2). And this was first originated from Wuhan in China and then spread worldwide and hence named as a pandemic disease. The first case of COVID-19 in Africa continent was reported from 2 countries, Nigeria, Egypt, and South Africa, in the mid of February and early March 2020. In Tanzania, the first case was identified on the 46th female odd from Belgium, and then was identified on the 6th March 2020 in Arusha, Mount Meru Hospital. To say on the epidemiology, as you can see the figures there, the numbers are so high due to the following reasons. The severe acute respiratory syndrome virus (COV-2), which cause coronavirus disease, it is scientifically an RNA disease, which now undergoes different mutations. Mutations meaning that it is changing its genetic makeup. And due to its ability of undergoing mutations, this virus produces different variants. The different variants of SARS-CoV-2, they have been classified in 2 groups by WHO. We have the variant of concern and the variant of interest. Variant of concern are the variant originating from mutation of the virus from the original virus and causing a severe form of disease compared to the original virus. The variant of concern is now affecting almost 4 areas. We look on the severity, the violence. We look on the speed of transmission. We look on its impact to the effectiveness of vaccine. And we look at impact on the diagnostic test. So the variant of concern, they have shown to have high virulence, it means they are very severe. They have high speed of transmission, and they have impact on the vaccines. An example of this, we have the Delta from India, we have the Alpha variant, we have the Beta and the Gamma. But the variant of interest, these are the ones which do not cause the severe form of the disease. An example of this is Lambda. So, WHO recommended the following so as we can be able to fight against the coronavirus disease. 1, we should keep the physical distance at least 1 meter from others. We should wear a well-fitting mask. We should open windows to improve ventilation. Also, we should avoid a poorly ventilated or clouded spaces. Keep hands clean by sanitizers and washing with running water and soap. Carve or sneeze into a belt elbow and get vaccinated. So far, these are the recommendations from WHO for us so as we can fight against coronavirus disease 19. The WHO, due to its, you can say, the ways to fight against disease, they started to work on the vaccination. Despite this virus is undergoing mutations now and then in such a way that it is very hard to target the real virus because every day it is undergoing mutations, they are undergoing changes. But the researchers and scientists have managed to come up with 4 types of vaccines, which actually they have shown a great improvement in 3 parts. 1, they have reduced the severe form of disease. 2, they have reduced the hospitalization of patients because it has a good chance to still replicating in many ways while in the body and causing severe forms. And many people died because of this. But after the vaccination, now we can see we have the reduction in severe form of disease. Despite some people are getting sick, they get all the symptoms, but once vaccinated, they never, at least nowadays, we have reduced the number of people going in ICU, needing oxygen, needing ventilators. So they are being treated pharmacologically in a normal way, and then they recover and they go home. So these vaccines, there are 4 vaccines. We have the inactivated or weakened virus. Example of this, it is Sinopharm, which is now currently in the country, Sinopharm vaccine. And one has to get 2 doses. Once you receive 1, and after 28 days, you receive another dose, then you are complete. This vaccine, we can say it is inactivated or weakened virus. They have taken chemical or the virus and made a vaccine whereby it's going to produce antibodies which will fight against the coronavirus disease and hence reduce the severity. Also, we have the protein subunit. And all this, the other three vaccines, protein subunit, adenovirus vector, and mRNA, these have been made from the protein. As you can see, the virus has got these knobs of the around the vaccine. That protruding knob, it is helping the virus first to adhere to the cell and hence enable the penetration into the body. So they have taken the proteins from those protruding knobs to make these vaccines. And hence, once you get infected with this virus, they will inhibit in one way or another the entry of the virus into the cells and hence reduce the severity of the disease. On the last month, WHO also announced another variant of the severe acute respiratory syndrome SARS-CoV-2, Omicron, which was identified from South Africa. This variant, although the studies are still undergoing on, but it is said that this variant of virus, it is now undergoing more than 50 mutation compared to the last Delta, which was very obvious in India and killed many people. The Delta had 9 to 10 mutations, but it killed many people in India and around the world. Now we are trying to question this Omicron, which is undergoing 50 mutations. We can say 3 times than Delta. And it has affected more people in South Africa. And now this does not affect the elder ones and people with comorbidities, but also it has seen now affecting even the university students. Because it means it does not now, this is now affecting all the groups, the elderly and the younger ones. And it seems it is transmission is very high, and it is we can say it is the effectiveness of vaccine of this Omicron is still on discuss. But from the WHO, they still say that anyone who has got a vaccine, against COVID-19 can get reinfection or can get infected, but will not get the severe form of the disease, will be hospitalized, but will not, also it will reduce death. So my take home, I will advise you to take vaccination, because until now this Omicron in South Africa, but in Tanzania not yet identified. Once it will be identified, let it find us vaccinated. Thank you.
Thank you, Dr. Avitus. We have not many questions at this session. We have only 3 questions, which are more or less, I think you can sort them out. I'll just go through them right now. On the paper, there is question number 1, which is coming up with why and are black people more vulnerable to the hypertension, not white people? This is the one which I think is in the paper. Another question from an anonymous drinker asks, why consumption of more than 75 mils of alcohol per day is risky to the health and it can lead to hypertension? What is your source of data, and give us more insights to this phenomena? So, an alcoholic like me need more information about it. Another question which I got, which will be the last one on this session. We have COVID-19 creates enormous stress to many. How do you balance your life amidst this stress as a doctor? Thank you. The questions are there.
Okay, to start with the first question, why and how black people are more vulnerable to hypertension than the white people? To answer this question, this ethnicity all different in black and whites. It was identified by comparing the patient being diagnosed with hypertension in blacks comparing with people affected with hypertension in whites. The black ones were found to have high hypertension compared to whites, and some of the reasons which were given, it is the kind of life we are living in. Because one of the cause of hypertension, as I said, it is stress, but also in the genetics, it was found that the hypertension in blacks, it is highly inherited from one generation to another, because it is found in most population, and hence it is inherited compared to the whites, which do not have that trait in their genetic makeup. So it is not inherited as compared to black ones. So in the genetic makeup, there is a trait of hypertension. That's why there are other people, they do not have any risk factors which can lead them to hypertension, but because of the family history, they have hypertension. And once you come to the hospital and you are diagnosed with hypertension in Africa, you will be asked, nyumbani kwenu kuna mtu mwenye ugonjwa wa pressure, either baba au mama? Ukisema ndio, tunaanza kufikiria kwamba this can be genetic, baada ya kuwa tumesha exclude other risk factors. Kwa sababu mtu mwingine unamuona ana any risk factor kabisa, yuko vizuri, lakini ukimuuliza kati ya nyumbani kwenu, wazazi wako, baba, mama, babu, is there anyone with hypertension, atakwambia mama anatumia dawa ya pressure. That's why it is more common in blacks. The second question, you say that consumption of more than 71 mils of alcohol per day is risky to health and can lead to hypertension. What is the source of that? Second, what alcohol concentration is referred to it by percentage? Okay. The source of data, it is WHO and CDC. You can go in WHO and study on articles pertaining hardcore with hypertension. You're gonna get the clear. You're gonna get everything from there. About the article concentration, what article concentration is referred to in percentage. This I cannot say at this time. Maybe I will answer you when I will find the clear percentage. COVID-19. How do you balance your life amidst these threats and risk? As you know, this disease, me and the others, health practitioners, when we were receiving patients with COVID in the hospital, in the beginning, actually, we were also having a fear that we can be infected. And so, but we tried our level best to assist the patient. Although sometimes you can see a very severe patient in such a way that there are some, you can miss doing some investigations or because of fearing. Because as a doctor, you have to ask the patient, but also you have to touch. So for example, the patient with pneumonia, you have also to listen to the chest. And now, contamination with the patient with the COVID is also a way of transmission. So at first, we were very, very afraid and at risk. But currently, we are now confident because of the vaccine. We are very confident. And kuongea ukweli, ukiwa wodini unamwona mgonjwa mwenye COVID, wengi wao even kwenye afya sisi, kuna wengine ambao bado walikuwa wana doubt kuhusu chanjo, lakini walivyokuwa wanamuona mgonjwa anavyohangaika, yani hata kama ulikuwa unaogopa, una decide kuchanja. You can imagine a pregnant woman ana mtoto tumboni wa miezi 6 mpaka 7, then comes with a very severe symptoms of COVID. Amekuwa supplemented na oxygen mitungi miwili huku na huku, and zote ziko full, lakini still anaendelea kumuita daktari. Anaambia daktari, njoo nisaidie hewa spati. You have done everything to your level best. Umeshampatia madawa yote, umeshasupplement na oxygen mitungi mwili, face mask na naso, na ziko full zote. Still analia, anakuita. Ukimwona pale, ukipima kiwango cha oxygen in the lungs, it is 10. The normal saturation should be above 90. Kwa hiyo mtu unamuona anakufa live na mtoto wake tumboni. Then fortunately unakuta familia wana uwezo. Ukiandika, kwa sababu the drugs are given according to severity. Unaandika dawa ambayo ni dozi 1,120,000. The husband goes and bring haraka haraka, inaletwa hapo hapo, mnamchoma. SPO2 inashuka 8, 7. Yaani mpaka anakufa mnamuona hivi, hamna cha kufanya kingine. Lakini currently maodini hatuna wagonjwa wanaotumia oxygen baada ya kuwa watu wamepata chanjo. Kwa hiyo also tunajivunia, yani tunakuwa tuna evidence kwamba chanjo tukifanya now a study, chanjo imeleta effectiveness kwa kureduce severe symptoms na hospitalization, even death. Kwa hiyo mimi nimechanja na wewe naomba uchanje pia.
Naomba tumpigie tena makofi ya nguvu. We are wrapping this session whereby our throats now are getting thirsty to get to the next stage. So namkaribisha kwa ajili ya program presenter. Program manager.
This is how it feels when Mugishagwe meets Mutalemwa. Nafikiri mtakubaliana na mimi hapa, mimi ni Mjita lakini siwaingize kwenye kesi. Hapa tumeona how Ugambire they did their things. Hongera sana Mugishagwe na Mutalemwa. It was really nice one. Now naomba mnikubalie nitoe logistics announcement for our cocktail arrangement. You may have your seat. Venue yetu ni New AICC Club ambayo ipo karibu na roundabout ya Kijenge. Tuna shuttle 7 ambazo ziko hapo nje, na kuanzia saa 12:30 we are scheduled to start our move kwenda mjini, na event yetu tunategemea itaanza saa 1 na kuisha saa 3, na kwa ambao wako along this side ya Usariva na Ngurdoto, zile shuttle ambazo zitachukua watu hapa zitawarudisha tena, zitawapeleka mjini na kuwarudisha, na kwa wale ambao watakuwepo wako wamereside kule mjini tunaweza tukaondoka nao and then wakifika kule mjini wanaweza kaendelea. Kwa hiyo ni New AICC Club, iko karibu na roundabout ya Kijenge, kuna shuttles ziko nje, na tunakutana kuanzia saa 1 mpaka saa 3 usiku, na kesho tunaendelea kuanzia saa 3 kamili. Nashukuru sana kwa ushirikiano wenu na asanteni sana.